Isolated footing, one footing in your building. To start to calculate or to design this footing, we need your total dead load reaction alone and your live load reaction, total live load reaction alone. So from the floor, you are able to get your dead load reaction alone and live load reaction alone. If your reaction for one floor, you need to multiply this reaction by how many floors do you have in your building. So first step in your design, what is the total surface load, dead load plus live load without any factor? What is the total factored load, P ultimate equal 1.2 dead load plus 1.6 live load? Then you have to figure out what is the dimension of your footing, length and width. But before this, we need to figure out what is the total thickness of the footing. Total thickness equal depth plus cover. We are going to use 4 inch as a cover, 3 inch, maybe 5 inch, that's okay. Your depth, and just for your information, here is your steel reinforcement. HF is the total thickness. D is the depth, so the distance between the top to the center line of your reinforcement. Anyway, if your column is rectangular, we can use this equation to figure out what is the value of D. If your column is a circular column, we can use this equation to figure out what is the value of D. Just for your information, B and C are dimensions of column. So before starting to design isolated footing, we need to design column first. And we learned last time how to use Excel to design column. Phi mu C can be phi 0.75, mu C equals this value, lambda equal 1 for normal concrete, and B ultimate, your total factor load. Once you solve this equation for D, add your cover to get the total thickness. Next step, what is the dimension of your footing? Before this, we need to figure out what is the Q net, soil pressure equal Q allowable, which may be called peering capacity of the soil, minus HF gamma concrete minus gamma soil. Here is the ground surface. To pour your footing, we need to excavate some soil and put your footing. So this distance HF, you excavate soil and put another material which called concrete. So if you would like to calculate the Q net at this location, you can subtract the bearing capacity minus HF times gamma concrete, which is 150, minus gamma soil based on what is the type of soil you excavate. Area required, this area of footing should be equal or greater than surface total reaction, which equal B dead load plus B live load divided by Q net that you calculated before. Once you get area required, if your footing is rectangular, you can assume one length and choose the second one. If your footing is square, you can get the length by square root of area required. So right now, I'm done with the total thickness, I'm done with L, I'm done with W, the dimension of footing. To calculate how much steel reinforcement you need, so I'm going to calculate what is the distance between the face of the column and the edge of the footing, which called LM. So you can figure this out. And what is the Q ultimate? Equal P ultimate divided by area of footing. If your footing is rectangular, so B times L. Or if your footing is a square, so B square. Anyway, so right now, I can calculate the distance between the face of your column and the edge, and what is the Q ultimate. The idea behind this point, here is your footing, here is the column. So we have P ultimate from column equal 1.2 dead load plus 1.6 live load. This column will apply pressure on the soil, so the soil will react with pressure on the footing. This pressure equal Q ultimate. I calculated Q ultimate. At the edge, at the face of your column, at this face, I will calculate how much moment do you have. So I will assume this length as a cantilever fixed here. You have pressure coming from soil to the footing equal Q ultimate. This length equal LM. So I can figure out how much moment do you have here. Your moment equal, from structural analysis, Q ultimate LM squared divided 2, and I will assume this moment for unit width or unit length of the footing by cancelling B, the width of the footing, by cancelling B. Forget it. So your moment for unit length, your steel reinforcement for unit length, everything for unit length for 1 feet. Once you get your moment, go ahead and calculate what is the rho required, and the rho required equal area steel required divided by your D times 1 feet, unit length. Once you get your area steel required, please check your area steel to be greater than the minimum and smaller than the maximum. Maximum spacing between bars should be 18 inch or less. One more thing. So after this step, we can figure out what is the dimension of your footing and how much steel reinforcement required in this direction and required in this direction. That's fine. But we need to do two checks. The first check, two-way shear or called bunch. Check. Check of bunch. I'm worrying that this footing is too thin and this column carrying too much load. So what do you think? I'm worrying about this phenomenon. Can you see? What happened? This is called bunch. Your column may be thin, carrying too much load. Your footing is too thin, the thickness. So maybe you can expect bunch in this area or on this area. So we need to check. We can call it two-way shear or check of bunch. It's very easy. Just around your column by distance by distance D, divide 2. D divide 2, D divide 2, and from the other side, D divide 2. So here is your column. This distance, D divide 2. 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 So I expect my column will take this area and bunch this footing. So here is the critical cross section or critical section of bunch. What is the area for this shape? This distance will be C plus D. This distance will be B plus D. Remember, your column is B and C. I added D divide 2, D divide 2. So what is the total length here will be? D divide 2, D divide 2. So it's D. And we have B, so this distance will be B plus D. This distance, D divide 2. This distance, D divide 2. So this total distance will be C plus D. So the area, this area with the column will bunch your footing. So we have a perimeter called B naught equal, this perimeter equals this length. This length plus this one, plus this one, plus this one. So C plus D times 2, C plus D times 2. B plus D times 2. I can get the perimeter. I can calculate something called V ultimate 2 equal B ultimate minus Q ultimate time this the area, B plus D times C plus D. Then this value, V ultimate 2 should be, not should be, must be smaller than or equal this equation. And the smaller than or equal this equation to say here is the bunch is safe. So
If it's greater than, that means it punches. If it's less than?
if this one is smaller than, your bunch is safe. If this one is greater than, no, you can expect bunch from the column to this footing. So this value must be smaller than or equal the resistance value. Your resistance value, we have phi, we have beta, we have lambda, we have FC prime, we have B naught, we have depth. Phi equal 0.75, beta is the ratio of long side to short side of the column. Your column, the long side divided by smaller, shorter side. If your column is a square, beta will be 1. If the column is a square. So go ahead, lambda equal 1 for normal concrete. Lambda equal 1, so I can figure out the right side of this equation. The left side equal B ultimate, we calculated B ultimate. Minus Q ultimate, we calculated Q ultimate. C plus D, B times B plus D. Why this formula? I told you the critical section for bunch, just D divide 2 from each side of your column. So what is this area? This area will be B plus D times C plus D. The perimeter for this area equal 2 time plus 2 time. So we have to check of bunch. But if you have good column, not less than 10 inch times 10 inch, if you have good thickness of concrete for your footing, I expect bunch will be safe. I can tell you the bunch will be safe. All of these calculations based on two things: column dimension and footing thickness. or footing depth. They are the two main factors to check of bunch. Once your bunch is safe, go ahead and do another check of shear. This time called one-way shear or shear. Check of shear, something looks like bunch, but a different cross section. From one side of your column, walk distance D, not D divide 2. Walk distance D and get a section. The remaining distance to the edge of your footing, we can call it L prime. Go ahead and calculate your L prime by any way. Remember, center line of column is the same like center line of your footing. So if you would like to calculate this distance, you have many ways. The first one, what is this distance? Do you know? B divide 2. This is the total distance of your footing. Subtract this little distance, which is C divide 2 of column. Subtract this distance, D. So I can tell you the remaining distance L prime equal B divide 2 minus C divide 2 of column minus D. I can get the remaining distance L prime. One more thing, one more time. I don't care about these equations. I don't like to remember these equations. I don't like to use them. L prime for one sentence. Come to your face of the column. Walk distance D. D is the footing depth. Any question? At this location, draw cross section. Can you tell me what is the remaining distance of your footing? L prime. Okay,